Hello friends, today's question. A wire of length 2L is made by joining two wires A and B of same length but different radii R and 2R and made of same material. It is vibrating at a frequency such that joint of two wires forms a node. If the number of antinodes in wire is P and that in B is Q, then the ratio of P is to Q is. So this is the given figure. Two rods A and B individually having a length of L and L, so total length is 2L, and at the joint it says that it forms a node, and we have to find out that if A is having a P number of antinodes and B is having a Q number of antinodes, we have to find out the ratio of P is to Q. So we start from the length of the rod and try to find out what will the wave velocity and the linear mass density and the relationship between the volume and the various speed, and then we can find out further things. So we say the total length of the rod is 2L. Total length of rod is given as 2L. And we know that the wave speed that is our V, it is given as T upon mu, where T is the tension and mu is the linear mass density. So T is the tension, and this tension will be same for both the wires, which will be same for both wires since they are joined together and are under same force and mu we know is our linear mass density. Mu is our linear mass density. So we can write this formula as mass oblique length. So obviously this will be a little bit different for both the wires. No doubt the length is same, but the mass we can write as density multiplied by the volume. So their volume will be different because of different radii. Density will be same for both the cases. Now let's find out the relation between the linear mass density and the radius. Relation between linear mass density and radius. So both the wires are made of same material. It is given the question, it means their density will be same. So we say since both wires are made of same material they have same density. Same density, and the length of them is also given same, and length of the rods is given same. So density will be same and the length it is already given same. And we know that the density is our mass over volume, and volume will be equal to cross-sectional area multiplied by the length, and volume will be equal to cross-sectional area multiplied by length. Cross-sectional area multiplied by the length. Obviously, the cross-sectional area for both the rods will be different. So we can write that our volume, if represented as V, will be equal to pi r square multiplied by length L. So from here we can say that our mass is equal to density multiplied by the volume, and we can write that our mass is equal to rho multiplied by pi r square times L. So therefore the linear mass density, therefore mu, which is our mass oblique length, this comes as rho pi r square L divided by L, and here length and length cancels out, so this comes as rho multiplied by pi r square. And from here we can also write that our linear mass density is directly proportional to radius of square. Now we are going to modify, let us suppose this equation 1 for wire A as well as for wire B. You can say using equation 1 for, first is our wire A. So we can write it as mu A is directly proportional to radius of A, its whole square. Radius of A wire is given as r, so therefore we can say that our mu A is directly proportional to r square. And for wire V, we have mu B is directly proportional to radius of B wire, which is given as twice of r, so this becomes mu B is directly proportional to 4 times r square. So we can easily find out their ratio. We can write that mu A upon mu B is equal to r square upon 4r square. R square and r square cancels out, and this gives us 1 upon 4. So we found out the relationship between their respective linear mass density. Now we come back to the equation for the wave speed. Wave speed is our V and T upon mu. Let us call this equation number 2. So we can write this equation 2 for both wire A as well as wire B. Using equation 2 for first is our wire A, we can write that our VA is equal to, tension will be same, let us suppose that is TA and this is mu A. Then it is our wire B, which we can write VB is equal to tension divided by mu B. And we can find out the ratio that VA upon VB will be coming equal to as square root of mu B upon mu A, and this is, we already know, this is our 4, which comes as 2. So we can say from here that velocity, wave speed in string A will be equal to twice of wave speed in string B. Now it is almost complete. We come to the last part, that is the relationship between the frequency and the wavelength. Frequency and wavelength relation. And that is our lambda is equal to wave speed divided by f, where f is the frequency. And it is given in the question that both the wires are joined together, so therefore frequency will be same. So you can say since both wires are joined, frequency f is same. So if frequency is same, we can easily modify the equation as for wire A, we can write that for wire A we have lambda A is equal to VA upon frequency, and for wire B we can write it as lambda B is equal to VB upon frequency. And we already know that VA is twice of VB, so from here we can say that our lambda A will be equal to twice of VB divided by frequency of f. So we have two equations, lambda A as well as lambda B. And in the question it is given that A wire is having P number of antinodes and B wire is having Q number of antinodes. So we are given that number of antinodes are P and Q. P is in wire A and Q are in wire B. And we know that the number of antinodes of a wire which is having a length L is proportional to the length of the wire divided by half the wavelength. So you can write that number of antinodes in a wire of length L is proportional to is proportional to length of the wire, divided by half the wavelength So basically means length divided by half the wavelength. So let us write this for wire A as well as wire B. So we can say therefore for wire A we can write that a P is proportional to length is same in both the cases. So this will be length divided by lambda A divided by 2, and we can write for wire B we have Q is proportional to length upon lambda B divided by 2, and from here we can write that our P upon Q is equal to L lambda A upon 2 divided by L lambda B upon 2. Here length 2 and 2 cancels out, and this comes as our lambda B divided by lambda A, and which we already know that we can say that our P upon Q is our lambda B upon lambda A, and lambda B is upon VB by frequency F. So this is VB by frequency F, and lambda A is our twice VB upon frequency F. So now the VB frequency cancels out, and this comes equal to 1 upon 2. So therefore ratio P is to Q is 1 is to 2. So this is the ratio of antinodes. This is the ratio of antinodes in, let's keep it like that only. And the options that are given to us, the option number C is the correct one. So you can say option C is correct. C is correct. So this completes the question. Thank you.